we're going to look at neutralization reactions. These are reactions between an acid and a base, and neutralization reactions are double replacement reactions. So the general reaction is that you have an acid plus a base yields salt plus water. Remember, water is a covalent compound, so it can make a double replacement reaction possible. When we say a salt can be, it doesn't have to be table salt, sodium chloride, it could be any ionic compound. So a metal and a non-metal compound. Okay. So some definitions: that an acid produces hydrogen ions. When it's dissolved in water, and a base produces hydroxide ions. When it is dissolved in water. Those are the Arrhenius definitions. They're pretty strict definitions. A more broad definition is that an acid is a proton donor. And by proton, it's the same thing as saying hydrogen ion. So proton and hydrogen ion are the same thing because most hydrogen atoms don't have a neutron. So if they lose one electron, all that's left is one proton. So it's literally the same thing. It's kind of funny that we call that. Anyway, and then a base is a proton acceptor. Like I said, there are compounds that will fit in the Bronsted-Lowry definition that won't fit in the Arrhenius definition. Let's review what we know about litmus paper. You'll need this in lab if you haven't used it already. So if pink litmus paper is dissolved in, or dipped into a solution and it does not change colors, that means that the solution it's not basic, and it could be acidic, or it could be neutral. If pink litmus turns blue, that means the solution is basic. If both pink and blue do not change colors, that means the solution is neutral. Anyway, so moving toward pink means acidic, moving toward blue means basic. Let's look at what they do when you put them in water. So acids look like covalent compounds because they're nonmetals only, but as we've said, acids act ionic when you put them in water. And so what happens with hydrochloric acid, one of our strong acids, is this hydrogen in front is what breaks off, and it is always the hydrogens that are at the front of the acid formula, even if it's something, you know, like H3PO4. Those hydrogens that are in front can break off as ions. Okay, so this is how it produces hydrogen ions in solution. Those break off. This second one is an interesting case because it is a base. Most bases are hydroxides. The strong bases are hydroxides like potassium hydroxide, calcium hydroxide. But this one is a base because it's a proton acceptor. And this is the proton. Notice this is a funny way to write water, but that's how we do it, because in this case, one of those hydrogens is going to come off, join this molecule, which is ammonia, and this is ammonium. So it breaks off, it forms this, and of course this is what's left of the water. Now one thing you might notice is that this top one, the acid, the arrow goes just one way, whereas here the arrow goes both ways. And if the arrow goes both ways, it means that the reaction is reversible. In other words, when these become the ion form, sometimes the two ions get together and go back to the molecular form. And then they may go back to being the ion form. So the reaction is going back and forth both ways all the time, which means that at any point in time, you're going to have all four of these species present. Okay. That's different than with the hydrochloric acid because these break apart and stay apart. There's no reversible reaction. So this will be 100% ionized because it breaks apart and stays apart. This will not be 100% ionized because it keeps going back and forth. So this we call strong. It will be 100% ions, and this we would call weak because it's not going to all stay in the ion form. So strong acid and base means it'll be present 100% of it in the ions, 100% ionized. So the words strong and weak are the same as they were with electrolytes. So strong acids and bases are strong electrolytes. Weak acids and bases are weak electrolytes because they both refer to the number of ions in solution. If you want to pause and think about these before I go through them, you can. Okay, which of these is a strong electrolyte? Well, if we look, this is the easiest question because this one is a strong, hydrobromic acid is a strong acid. We should have that memorized. And just in case there's other compounds given, what we're looking for, strong acids or bases compounds that have the ionic compounds that have the 6 soluble ions, or ionic compounds with the symbol AQ. Those you know are always going to be strong electrolytes. What about a weak electrolyte? That was our strong. A weak, this is a weak acid. And how do I know it's a weak acid? Well, I know it's an acid because it starts with H. And I know it must be weak because it's not one of the 7 strong acids that I've memorized. Okay, and then last, of course, it looks like we're going to have this compound. Well, how do I know that? Non-electrolytes are covalent compounds. They don't ionize when they dissolve in water. unless they're acids. Remember, the acids do, they act ionic, but other covalent or molecular compounds don't. So okay, or we're going to look for ionic compounds that don't dissolve in water, like the precipitates. So back to our neutralization reactions. As I said, these are double replacement reactions, and this is the general reaction. Acid plus base yields salt plus water. I put a question mark because it actually depends on the base, if it's a weak base. But for ours, it will be water. And the salt comes from the ions that are present in the acid and base.